Hello, we are going to do a lesson on the product rule. This is 7.3. This should be a pretty quick lesson. It's our first of the exponent rules that we will be learning. So as a review, a product is the answer to a multiplication problem. So that is going to give you a hint. About what the product rule is going to be about. We're going to be multiplying. The product rule tells us that when multiplying two powers with the same base, and remember we learned about the parts of the powers in our first video of the unit. So when you have two powers with the same base and you're multiplying them together, you can add the exponents. As a general rule, a lot of times when we learn a rule in math, they will show you how the general rule looks. X to the m times x to the n, that will actually be x to the m plus n. If you don't like that notation, this notation, or you don't understand the rule in all variables, that's okay. I just wanted to show you how that looks, because that is a lot of times how rules are expressed in math. They'll show you the rule with all variables. Let's actually get some practice on using this. But first, let's talk about why this works. It really is just a shortcut that you can remember. When you're multiplying powers, you can add the exponents with the same base. That's the kicker. But let's see why it works. So for example, if we had oh, that's way too big. I tried to make it bigger, but I did not realize it would be that big. Let's try again. Let's see if this is better. If we had 4, squared times 4 to the power of 5, then we would have, essentially, we'd have 4 times 4, because this is the number times itself, how many times? So we've got 4 times 4 times 5 more times. 1, 2, 3, 4, 5. So essentially what we have is 4 times itself 1, 2, 3, 4, 5, 6, 7 times. To make that shorter, this looks like our general rule. We have 4 times 2 plus 5, which is 4 to the 7th power. So see how that works? Now we can see it's really just a shortcut. What we're actually doing is this kind of long, drawn out 4 times 4 times 4 times 4 times 4 times 4, right? We can express it and get there to the same answer much more quickly if we just add the exponents. Now let's get into some examples like you will see on your assignment. All right, more examples. So here we have x to the 7th power times x to the 4th power. We know that is x times 7 plus 4, x to the 11th power. And again, I would highly, highly encourage that you pay attention to these examples, because there is a 99% chance that you're going to see these again in the very near future. Hint. Wink, wink, wink. Okay. Second one. We haven't seen one like this before, but we're going to work it here together. So we know that if we don't have an exponent, then that's good. It's one time. So it's like x to the first. And now we've got coefficients here. So what we're going to do with those is we are going to multiply those together. I'm going to write this out in expanded form so you can see how it looks. We've got 3 times x times x times x times x times x times 2 times x. So these are all multiplied together. So now let's put them, because we can rearrange multiplication, let's put them in order to put our like terms near each other, our variables near each other. So we've got 3 times 2 times x times x times x times x, x, x. Ooh, a lot of x's. Now, let's simplify further. What's 3 times 2? 6 times x to the 1, 2, 3, 4, 5, 6. And that makes sense too, because 5 plus 1 is 6. So we're going to, as a note, multiply the big numbers. Those are called the coefficients. And add the littles. And those are the exponents. Okay, so you're going to multiply the coefficients. They do still have the same base. This is the base right there, the x. And then add up the exponents. Let's do our one last example that we have here. So this is a little bit different again because we have 2 different bases or 2 different variables that we're working with here as well. Or again, this is a 1, an invisible 1 because there's nothing there. So we'll focus on one at a time. We've got our x base right there and right there. When there is nothing in front of that negative sign, we know that the negative x is like negative 1x. So you have 7 times negative 1, which is negative 7. Our base is x. And then how many x's do we have? We have 1, or how many times are we going to multiply x by itself? We got 1, 2, plus 4. So 2 plus 4 is going to be 6. Now we'll do the same thing with the y. We've got 1 times 1 because there's no coefficient that we can see, so that's an invisible 1. So that is just y. We got 1 y here, y to the first, plus y to the 6th. That's 7 of them total. So our answer is negative 7, x to the power of 6, y to the power of 7. So I would make sure I understood these examples here because these are the 3 kind of different kinds that you will see on your homework. And if you have any questions at all, please reach out to me. You know how to get a hold of me. I would love to help you. And once you feel like you understand this and you have your notes, then go ahead and hop onto Google Classroom and try your assignment. I hope that you have a great day.